Hello and welcome to Sudoku. This is an average Sudoku puzzle. Well, average Sudoku is the name of the variant. It's not an average puzzle, it's a very good puzzle. It was featured on round 5 of Sudoku Mahabharat, which was constructed by Hemant Kumar Malani. And it was the highest pointer in the round, and it was definitely the hardest puzzle. But it was reasonably approachable, I think, once you understand a few things about this variant. But first, I'll explain the principle. The rule is that whenever you have a line like this, a segment, it means that the corresponding digit is the mean value of the two surrounding digits in the direction of that segment. So this one is the mean value of those two digits, and this one appears to be the mean value of those two digits and of those two digits. And one last thing is that all possible lines are marked, which means that this digit is not the mean value of this one and this one. And all over the grid it's the same. So where should we start? Well, these two, this 9 are places to start. But first, let me explain something. When some number is the mean value of the surrounding two, let's say for the sake of example 1, 4, and 7. 4 is 1 plus 7, 8 divided by 2. It also means that the distance you have from 4 to 1 is the same as 4 to 7. If here you get to decrease by 3, then here you get to increase by 3. Or another way of looking at this, of envisioning this, is to have the same increment when you get from the first to the second digit and from the second to the third. And if you look at it this way, it's much easier to see what comes out of these two. It won't be 2, 3, and 4 because of this 4. It won't be 2, 4, 6, obviously. It could be 2, 5, 8, but anything bigger here would result in a much too big digit here. So the only way of fulfilling this clue is to have 2, 5, 8. The remaining digits on this row must be 1, 3, and 7, and because of 3 and 7 here, we get a 1 here and 2 candidates for those two cells. Now let's have a look at this 9. The possible triples that stem from this 9 are 9, 8, 7, 9, 7, 5, 9, 6, 3, 9, 5, 1, with here a decrement of 1, a decrement of 2, of 3, and 4. Here we can't have 9, 6, 3, obviously. We can't have 9, 5, 1 because of this one, but the other two seem possible. Oh, I'm just noticing something. This 7 and this 7 tell us by standard Sudoku deduction that one of those two digits is a 7. And therefore this one won't be a 7. Nice. And actually, we get a 7 here by standard Sudoku deduction. It's often important when you're solving variants of Sudoku to use standard Sudoku techniques. Now look at this row. 2 can only be here. We still need 1, 4, and 8, so this is 1 over 8. This is 4 or 8. This is either of the three. Well, we'll see how it goes at some point. Let's have a look at this. It won't be 9, 6, 3 because of this 3. This 7 makes this one impossible, so it must be 9, 8, 7 or 9, 5, 1. Where do we look next? I think this is a good place to look. This one should be a good place as well. Let's have a look at this one. So going out of this 5, we could have 5, 3, 1, 5, 4, 3 if we decrease, and if we increase it will be 5, 6, 7 or 5, 7, 9. But this 7 forbids those two, and this one forbids 5, 3, 1. So it's 5, 4 and 3, and we get the 7 on top, and this 3. Well, 7 would have been more convenient with, more convenient to solve this one. Here we need 1, 8 and 9. There's 1 and 8 here. And is there anything that would be resolved by just looking at the negative rule? I don't see anything. But now this column has lots of digits already. So the missing digits are 3, 4, 6 and 8. No, sorry, 3, 4, 6 and 9. And the only way of having a suitable sequence here is to take 3, 6 and 9. That's the only way of fulfilling this clue. That's a 6 surrounded by 3 and 9, and we get a 4 on top. This, no, nothing. Oh, this 6 is not, oh, sorry, this 6 is here. Oh, but there's a 6 here. The remaining digits here are 3, 2, and 9. So we get 2 or 3 here, 2 or 9 there. Oh, but there. 2 here would make this a 3, and a horizontal segment would be needed. So this won't be a 2, that's a 9. We get this 3, this 9, and this 2. That's a good use of the negative rule. Down there we need a 2 and an 8, and I don't think we can decide with the negative rule. The negative rule. 3 must be here, surrounded by 4 and 5. And there again, I don't see anything with the negative rule. But this 6 has become powerful. So what are the options with 6? If we increase, we get 6, 7, 8. And that looks really possible. If we decrease, well, there's no other increasing option. If we decrease, we get 6, 5, 4, but this would leave no available value for this cell. So this is not a valid option. 6, 4, and 2 wouldn't work because it would put a 2 here, which would clash with this one. And then 6, well, no other option would work. So it has to be 6, 7, and 8. On this row, we still need 2, 4, and 5. Oh, but 5 wouldn't work here because then we would have 7, 6, 5, and a horizontal segment would be needed here. So this one is a 4, and the other two digits are 2 and 8. No, sorry, 2 and 5. And I don't think the negative rule would work here, would do anything. 3, 3, and 3, we get a 3 here. Let's do some standard Sudoku. This row needs 1, 5, and 8. So this is 5 or 8. And I just write the candidates. I still need a 4 and a 9 here, but I don't see anything about this. Oh, this 7 should be pretty powerful. There's not much room around 7. It could be 6 and 8, or it could be 5 and 9. And I think both are possible. So 6 and 8, or 5 and 9. Oh, but yes. I think that nothing would work with a 9 here. Well, 4 with a 9, it wouldn't work. We would have 6.5 in the middle cell, and with 8 and 9, we would have 8.5. So 9 can only go here in this column. And now those are 4, 6, and 8. So this one is a 6. Oh, and actually 4 is not available because of the given digits. And we get a 1 here. And an 8 there. No 8 on top. We still need 4, 5, and 8 up there. So this is 4 or 5. 4, 5, 8. These squares need a 5 and a 9. There's a 9 here. This 5 gives this 4. And this 5, 8 pair makes this a 2. That a 5. That's an 8. And a 7 to fulfill this clue. And this 8 resolves the 2, 8 pair. We're getting there. This has to be a 4. And 9 and 6 into those positions. Here we need 1 and 2. There's a 2 here. This one gives this 5. 8 and 5. A 1 here. Oh, and this 8 gives those 2. Here I still need 1 and 2. This one is a 3. And the remaining digits then. What are those? Down there I still need a 5 and a 6. So it's a 6 here, a 5 here, 6 and 4. Well, I won't bother just checking that everything works with the negative rule. I just trust the team who has prepared this round, meaning Hemant and the testers. So that was a nice puzzle. You need to have this way of looking at the average condition. That's really the most efficient. You need to remember to use standard Sudoku, standard Sudoku techniques, and I didn't have to resort to X-wings or exotic stuff like that. Just, standard stuff. And the negative rule really helped in a few instances. I remember ruling out 5 from this cell. That was very nice. Good puzzle. Thanks for watching this video, and see you soon on Sudoku.